Okay, so this is example 8 in your book that I wanted to go over. This is on page 157. And, oh, just kidding, example 9, not example 8, example 9. And, okay, so we're given a non-homogeneous differential equation, so y double prime plus 6y prime plus 13y equals, and then we have e to the negative 3x times the cosine of 2x. Okay, so here the directions say to determine the appropriate form, right, of a particular solution. So notice in the last few example, and on your exam, I'm going to ask you to find the general solution to the non-homogeneous equation, which is basically the general solution of the homogeneous equation plus the particular solution. So here they're just asking for the particular solution, but let's go ahead and find the general. Again, they're skipping a lot of skipping a lot of steps. So if we want to find, again, the main goal, right, is to find this guy. So again, this could be like number 1, number 2. So number 1, well, that's just going to be the roots. So let's find the roots of the characteristic polynomial. Again, you can read this in your book. You'll notice they're there. So this is going to be r squared plus 6r plus 13 equals 0. And if you factor this guy, let's see, you're going to get, well, actually, you can't factor it. If you tried to factor it, you wouldn't be able to, and that's why they have a complex solution if you're looking at the book. So actually cannot factor, right, with real numbers. So here, if you use the quadratic formula, we get r equals negative 6 plus or minus the square root of, let's see, b squared, that's 36 minus 4, a times c, all over 2a. And let's just scroll down. So r equals negative 6 plus or minus, okay, so this is going to be 36 minus 52, all over 2. We can just keep simplifying this a little bit. So r equals negative 6 plus or minus, let's just write over 2. And see, 36, so 46, 56. Okay, and let's see, we get negative 16, right? So we know we're going to get an imaginary solution because we have a negative under the radical. So we have r equals, right? This is just negative 3 plus or minus, right? And this guy is just going to be negative 4i, right? But we're going to divide it by 2, so that's going to give us 2i. Okay, so that's why they have the roots negative 3 plus or minus 2i. So we can write our y sub c, right, as, let's use our theorem from, again, I just want to refer to it since you're probably going to have it on your cheat sheet. So let's see, I want to say it's theorem, I think I just used it, Theorem 3 on page 131. So we have e to the ax, so e, again, this is my a, and this is my b, so e to the ax, that's a negative, and then times, so we have c1 cosine b, so that's cosine 2x, plus c2, and then we have sine bx, and again, that's 2x. Okay, so this is our general solution to the homogeneous equation above. Okay, so let me go back to just example 8 in your book. Okay, so then we have, so now let's find the particular solution, and so let's just call that 2. So if we want to construct y sub p. So if we choose y sub p, well, remember, how do we choose y sub p? Well, we go back to our equation, and it's going to be a combination, right? We have a cosine of 2x, so we're definitely going to use, we want to use a cosine 2x plus b cosine 2x. But we also have an exponential function. So we want to include that exponential function. So we're going to choose, and it was e to the, actually, was it negative 3x? Yeah, it was e to the negative 3x. So e to the negative 3x, right, times, and then again, we're going to have a, right, some constant, cosine 2x plus b sine 2x. And then I can start differentiating, right, if I want, find the second derivative, first derivative. But the reason I'm not going to is because this is not a good choice for y sub p. Because remember, this function has to be, right, we want to add something new to the table, right? We can't have the same, notice this expression, or this function is contained in our general solution to the homogeneous equation, right? It's, e to the negative 3x, okay, e to the negative 3x, and then some constant times cosine 2x. Well, I have some constant times cosine 2x. So it's the same thing. So it's just going to be redundant if we add the same thing. So we want something different. So when you have that, you want to, right? So this is the case of duplication that they talk about in the book, which you want to know for your test. Hint, hint, right? This means it's important, stars. So we have, so what do we do? So we have y sub p, instead of choosing this first guy, I'm going to do e to the negative 3x, and then I'm going to multiply this particular solution by a factor of x, right, to eliminate the duplication. So I'm just, again, going to write a times x, right? If I multiply it times x, I'm really distributing that x inside. So that's why they have ax cosine 2x plus bx sine 2x. So that is your particular solution. So when you write, well, of course, you write your yc plus yp, right? Well, we found our yc, and then again, yc is right here, and then of course our yp is this guy right here. And there's no, we're not adding the same thing. That function's not contained in y sub c. So just make sure you understand that. You should have some examples on your homework assignment for 2.5. So if you have any questions, you'll see some of this on the review. So you'll see students performing this case of duplication. So that is example 9 in your book. Again, very important for test.